This is our fourth lesson in Chapter 1. This lesson is all about proportional and non-proportional relationships. So we're going to get started with 3 vocab words. Our first vocab word is equivalent ratios. This is a word that you should be very familiar with. We're just getting a definition for it now, okay? Equivalent ratios are 2 or more ratios that simplify to the same ratio. Remember, the other method of finding equivalent ratios is by finding cross products to be equal as well. Okay? Proportional. Proportional is when we have a relationship between 2 quantities. And quantities means that we've got multiple numbers kind of going on in a relationship, and we are looking to see that we're constantly getting equivalent ratios out of those quantities. Okay, so we will take a look at what that word means, and we will see some examples. So we're dealing with a relationship between 2 quantities in which all ratios are equivalent. Okay, well, non-proportional, the prefix non means not. So this means that we have a relationship between 2 quantities where not all the ratios are equivalent. As soon as we find one ratio that is not equivalent, we know that it's a non-proportional relationship. When you're taking these notes, I know there's a lot of words going on here. Feel free to pause this video, rewind, take your time. These are important notes that should be put in your vocab section of your note packet. So let's take a look at a practice problem. Our example here says Mrs. Shuck is planning a year-end pizza party for her students. Soglia's Pizza offers free delivery, that's important, and charges $9 per medium pizza. Okay, so we first are asked to fill out this table. This is all in your notes, so you can fill this out along with me. If we buy one pizza, we know that we're paying $9 for the pizza plus $0 to get it delivered, so our total is $9. If we get 2 pizzas, that will be $18. $0 delivery fee, total cost $18. 3 pizzas, 3 times 9 is $27. No delivery fee, $27 is our total there. 4 pizzas will be $36, and 5 pizzas will be $45. So now that we have our table, the next thing that it's asking us, by the way, these are our 2 quantities, okay? One of our quantities is the number of pizzas that we order. The other quantity is the cost, how much we end up paying. So what we're looking for here is we want to see if those 2 quantities are always equivalent ratios. And we're going to test the ratios that we've created right here. All right, remember, money goes in the top, time in the bottom, and that will help us with Part B. Part B says, for each number of pizzas, find the unit price. Okay, so first one here is $9 for 1 pizza. That is a unit price, so we can move to the next one. Next, $18 for 2 pizzas. If we divide by 2, which is our GCF, we will get $9 per pizza as our unit price for that as well. Next, $27 for 3 pizzas. Okay, $27, 3 pizzas. If we divide by the GCF, which is 3, divide the numerator and denominator both by 3, again, we're going to get $9 per pizza. 4 pizzas costs $36. Okay, $36, 4 pizzas. If we divide by the GCF, which is 4, we're going to get $9 for 1 pizza. That is another equivalent ratio. Let's finish up our table and check our last possible piece of our puzzle here. We got $45 is the cost of 5 pizzas. Again, If we divide by the GCF, we divide by 5 in the numerator and denominator, we will get $9 per one pizza. So all of those unit rates, unit prices, all of them, they all are equal to $9 for one pizza. And when we know that all of our ratios are equivalent, then that tells us that our relationship is proportional. Okay? So this is all that we're working on today. We want to take some word problems. We want to set up the tables. We want to set up all of the rates that we can get out of the table, and then we want to test them to see if they all end up simplifying to the same unit rate. In this case, I didn't show all of my work. It's really slow for me to write on the computer, but if you wanted to, you could show the division, or we could do cross products here to prove that they all are equal to $9 per pizza. Okay, so let's take a look at this same problem if we made one little change. So, same setup. Mrs. Shuck is planning a year-end pizza party for her students. Normally, Suglia's charges $9 for each pizza. I'm going to underline that. And free delivery. All right, good to know. Today, they're running a special deal. If you buy 2 pizzas, the third pizza is free. Okay. So this is not in your notes. You can follow along, watch the video, or you can use some scratch paper to copy this down. Let's go through and figure out our costs in the table again. We know that one pizza still costs $9. 2 pizzas is going to be $18. But remember, if we buy 2 pizzas, the third pizza is free. So here we're buying 3 pizzas. That means we're paying for 2 pizzas, plus we're getting 1 free pizza. Okay, so 2 pizzas is 2 times 9, that's 18. Plus our third free pizza means that if we buy 3 pizzas, our cost isn't going up any more. Okay, 4 pizzas means we're paying for 3. We still have our free pizza that we're not paying for. So 3 times 9 is 27, plus $0 for the free pizza is 27. 5 pizzas tells us we're paying for 4. And don't forget we have that 1 free pizza. So 4 times 9 is 36, plus the 1 free pizza is 36. Okay? So now we can see that our table looks a little different than last time. 9, 18, 18, 27, 36. If we go to do our unit prices, okay, our first is $9 for 1 pizza. That's if we buy 1 pizza, $9 for 1 pizza. Then it's $18 for 2 pizzas. If we simplify that, divide by the GCF, which is 2, we're going to get $9 for 1 pizza as our unit price. Here things change. Now we're paying $18 for 3 pizzas. We simplify this, now we're dividing by 3. And we see that at this point the cost is $6 per pizza. These ratios are not the same. So because they are not the same, I'm going to use my not equal to sign. Because they're not the same, we're going to say this is a non-proportional relationship. Okay, non-proportional. I want you to think about that. I want you to think about that problem about the pizza place. And I want you to brainstorm for me. We're going to talk about this tomorrow in class. In what other ways could we change the original problem so that it's no longer proportional? What other deals could you come up with? Or what other pieces of the problem can you change to make it a non-proportional problem? I want to talk about this tomorrow. Jot a few ideas down. Okay? So here are the steps to finding proportional relationships, or determining if they're proportional or non-proportional, I should say. First, you're going to begin by creating a table. Here's a hint. If we're doing tables, Time goes in the top for a table, which means money goes in the bottom for a table. Strange, but you'll see why in our next video. Okay. After we find our table and fill in all the values, we're going to find all the unit rates. If all those unit rates are equivalent, then we've got a proportional relationship. If any rates are not equivalent, then it is non-proportional. One thing I want to help you with is to get started in your practice problems for this lesson. This is number 1 from your notes. It says, at Schuylkill Haven Area Middle School, there are 4 7th grade homeroom teachers. Each teacher has 24 students assigned to his or her homeroom. Is the number of students proportional to the number of teachers? So I'm giving you the table, teachers on top, students on the bottom. If we've got 1 teacher, there are 24 students assigned to that teacher's homeroom. 2 teachers means we've now got 48 students assigned. You take your time to figure out the rest. Here's your to-do list for this lesson. Finish your practice problems, make your flashcards for your 3 new vocab words, and when you're ready, you can move on to lesson 1.5.